Good morning, everyone. Hope you can see me and I'm audible. I'm Chamika Silva, who will be the coordinator for this technical session. And it's my pleasure to welcome you all to the technical session on technological interventions in agriculture at the 33rd PGIA Annual Congress. This session has 6 presentations, and by now, hope all the presenters are joining with us online. First of all, let me introduce you to the chairperson and judges. It's my pleasure to introduce the chairperson for this technical session, Professor Nimal Gunawardena, who is a senior professor attached to the Department of Agricultural Engineering, Faculty of Agriculture, University of Peradeniya. Dear sir, I warmly welcome you to this session on behalf of the organizing committee of 33rd PGIA Annual Congress. Next, I shall introduce the judging panel for this session. At this moment, I kindly request all the judges to switch on your video cameras if possible, so that everybody can see you while I am introducing you to the audience. So the presentations will be evaluated by Professor Metika Vithanage. She was a professor attached to the Faculty of Applied Sciences, University of Sri Jawadarapura, Sri Lanka. Dr. Ajit Gunawardena, Deputy Director at the Research and Development Section, Central Environment Authority, Sri Lanka. Finally, Dr. Harsha Kadupitiya, the Director of National Resource Management Center, Department of Agriculture, Sri Lanka. Thank you for your kind cooperations, dear madams and sirs. Now you can switch off your video cameras. Thank you again. Now I would like to cordially invite Professor Nimal Gunawardena sir to chair this session. Now it's over to you, sir. Thank you.
Thank you, Chamika, for introducing us and the welcome the judges. As you have mentioned that we have 6 presentations, and without taking that much of time, I'd like to make a few announcements at the beginning. Now for each presentation, we have allocated 15 minutes, that is 12 minutes for presentation and 3 minutes for discussion. And at the beginning of each presentation, recorded version of the presentation will appear on the screen. And then the relevant presenter will also appear on the screen at the beginning of the presentation. And he or she will be there to answer questions during the discussion time. And then the presenters must adhere to the time limit. And then one bell will be rung at 12 minutes. That is to indicate that the time is up for presentation. And at the end of 15 minutes, 2 bells will be rung to stop the discussion. And the session coordinator will record the time for each presentation and announce it at the end of the presentation. Also, please raise hand option to indicate the questions, and also click the lower hand option once you are completing the question. And the presenters must mute the microphone at the end of the discussion. And except for the presenters, the judges and who would like to ask questions can unmute their microphones, and the others should mute their microphones unless they wanted to ask questions. Now, these are the announcement that I would like to make at the beginning. And without making that much of time, taking that much of time, may I invite the first presenter that's on exposed study on expected utility of weather information, quasi-experiment on Sri Lankan paddy farming by NMKC Premaratna, A. Senaratna, and LHP Gunaratna.
Good morning, all of you. I'm Pilijindak. I'm going to present my research findings. My research topic is exposed study on expected utility of weather information, quasi-experiment on Sri Lankan paddy farming. Let's move to the introduction. The combination of weather input with other inputs finally produce crops and finally the profits for the farmers. Farmers generally risk averse to common agricultural risks, including climate and weather risk. Risk aversion due to lack of precise information finally contribute to the low productivity in agriculture. The weather information can derive certain expected utility levels in the mindset of farmers. Finally, based on this expected utility, they try to produce their crops. The weather information is basically generated by using scientific forecast or traditional weather forecast. When we concerned about Sri Lankan paddy farmers, they use both these two types of weather information systems. Poor accuracy of traditional weather forecasts have been identified due to the anticipated negative impacts of climate change. When we come to the research gap, Sri Lanka expects negative impacts of climate change in the future. The existing weather and climate information gap have been identified as a bottleneck which acts as a barrier to the climate change adaptation. But many studies have conducted to identify the forecasting methods, traditional weather, and how it can impact on people, or else the factors affecting for climate change adaptation. But the valuation of weather information as an input in the production system has not been carried out yet sufficiently. With that background, we will move to the research problem. The research problem is how Sri Lankan paddy farmers value weather information. According to that research problem, these are the research objectives: to identify the expected utility of weather information related to paddy farming in Sri Lanka, to value the weather information as an input in paddy cultivation. When we move to the literature review, we can identify certain researchers have conducted their studies to value weather information. The expected utility theory describes generally people are approximately risk neutral when the risk case is small. Therefore, the expected utility theory has been used to explain the economically important significant risk. When considered the valuation of weather information, it has been basically conducted with respect to the user's objectives. One such objective is maximization of expected utility, and it has been widely used for valuation purposes. Constant relative risk aversion, or CRRA function, has been considered as a concave utility function to quantify the expected utility levels of people in both ex and ex post studies. In ex post studies, the expected utility of weather information has been calculated by using real production data. Then when we concern about the difference and difference method, when we are doing a certain experiment in a quasi-experimental setup, when we cannot have pure randomization, we have to rely on this DID method, because DID compares the before and after performance of a control and a treated group. Because DID estimates the treatment effect while accounting for the unobserved variables or the variances assumed to be remain fixed over the time. Let's move to the methodology. The unit of analysis is single paddy farmers of Sri Lanka. Sampling was conducted by adopting multi-stage random sampling. Sampling size was 900. Then that 900 was divided into control and treated group. The study area was Anuradhapura, Ratnapura, Badulla, Hambantota, Kurunegala, and Batiklo. When we move to the study design, one farming organization from each DSD from each district was considered as the control as well as the treatment. Here, the control group did not receive any specifically designed weather information. Therefore, they used traditional weather forecast. In contrast, the treated group was given location specific weather information specifically designed for this study. The study period was from 2016 to 2018. The data collection was conducted with the pre-structured, pre-tested questionnaire, and the baseline survey was conducted in 2016. The end survey was conducted in 2018. The data analysis. We considered this CRRA utility function to calculate the expected utility. Here, the utility depends on farmer's initial wealth and the constant relative risk aversion factor. Assuming farmers allocate their land as the input to maximize their profits at the end. Then the previous year, it means without provision of information for the both groups was considered with respect to the given information in the later year. It means in 2018. Here, the expected utility is compared with respect to two time periods. Then EU represent the expected utility of the climate year 1. Then W naught is the initial wealth, and the net return for single crop, that is paddy, is considered. Then number of years in between these two we considered as a 1 year. Then the number of crop enterprises here 1, it denotes by M. Then W is the farmer's initial wealth other than from paddy. For the calculation of net returns, the quantity which is sold and the corresponding prices and the cultivation cost have been considered. For the DID, difference in different regression, it considered the dependent variable as the paddy yield per hectare per farmer. The dummy variables were considered to represent the treated group and the time period of the intervention and the interaction in between the time and the group. The coefficient considered from beta 0 to beta 3, and the beta 3 is the interaction of group with respect to the treatment. Let's move to the results. The male representation of the respondents were about 80%. The average farming experience in the both groups were about 13 years, and similar values were obtained as the results. The age of the majority of the farmers in both groups in between 40 to 60 years. The secondary education has been completed by the majority of the farmers in the both groups. When we move to the baseline survey and end survey, it is very clearly observed that in between control and treated group, the considered variables were differed. That's why we want to go to the difference and difference method for the further clarification. Here you can see average cultivate land, average yield, average net return for a farmer, average wealth, average paddy price, and risk aversion. These things are significantly different or significantly not different at the baseline survey. Then the same questionnaire was used to collect data in the end survey as well. Then you can find the difference in certain variables here. Therefore, DID regression was conducted to find out whether this difference is due to the treatment impact. Then the expected utility of weather information is calculated according to the CRRA utility function. Then control group was reported with a lower expected utility value in contrast to the treated group. Then the treated group was received around 4.3 as the expected utility value. These are non-monetary values, but according to these expected utility values, they have developed their mindset to utilize their resources. Then we will move to the DID regression result. Here you can see the interaction is significant and it is around 960. It means after the intervention to the treatment, then they have obtained higher yield with respect to the control group 960. It means the intervention is very successful. Let's move to the conclusion. The paddy farmers who use the specific weather forecast have derived high expected utility due to the reduction of risk aversion. As a result, factors of crop production have been utilized with a more confidence manner, and finally they have obtained higher yield, that is 960 kilograms per hectare. The limitations and future research direction. Due to the secondary data limitation at micro level, we have conducted this by using primary data. However, in future research, it is need to validate these results by considering the other variables and their impacts. As an example, the price fluctuations, impacts of inputs, and technology likewise. Then these results need to be validated by using future research. Not only that, the use of advanced risk elicitation methods are needed to use in the future research. Since we conducted here a preliminary study, and by using a very small scale risk elimination method. Based on these findings, now I will go to the recommendation. The use of scientific weather information along with the appropriate mitigation measures and management practices should be promoted to reduce the risk aversion in decisioning. Therefore, once we provide this scientific information, we can reduce risk aversion. Provision of weather information as an input. As an example, location-specific weather information packages will help to utilize their resources rationally and finally increase the output. Therefore, we need to produce this location-specific information packages. Then these are the references. Thank you very much. If you have any clarification, you are welcome. Thank you.
Thank you very much. Now the session is open for any questions, any comments?
I have one question. May I go ahead, sir?
Yeah, please go ahead, Professor Mentika.
Thank you very much for your presentation. I would like to know whether in your case, the control farmers are using all the weather variables, right?
Yes.
And in your case, the treatment group, you consider only rainfall.
Yes.
So how will be the combined effect for this the treatment group versus the control farmers?
Yes. In the control group, we cannot directly ask them to prevent all the existing weather information sources because that is unethical. Therefore, they have to have some kind of information. Then they need to rely on their traditional weather forecasts and some general weather forecasts, specifically which they can access through general media. Then the treated group, in contrast, they are given specific location related rainfall data, assuming they basically consider weather forecast means rainfall, even though there are certain other things like wind direction, those things, but we assume that paddy is mainly rely on that.
Okay, thank you.
Thank you.
Yeah, any other questions? I have one question to you. Now, these meteorological advisories are given by various organizations. I think the Department of Agriculture, NRMC, I mean, they provide it, and then IMI, they also do it as a pilot study. Now, how could you upscale this? Now, this is an experiment, but how do you upscale it and
Yes,
use it for the farming community?
in most of the cases in other countries, like developed countries, they have weather information packages on their demand. Then they can see the value of these things. As an example, if I experience that weather is most important, then I can customize my requirements according to it. Then there must be some demand driven information packages, but in Sri Lanka we cannot have that. Then if their expected utility is high, then if their value is high, basically derived through this information, then there is an opportunity to provide that kind of customized packages rather providing general information. But in Sri Lankan context, what we can see now, available information is not that much of customized. But if we have some idea about how people utilize these things in a more meaningful manner and what kind of value they derive through these things, then we can specifically cater to that small level farmers, and we can have more customized versions.
Thank you. Are there any other questions or any comments?
Yes, sir. May I ask one question?
Please go ahead.
I'm Kadupitiya. And have you any idea about the accuracy level of that weather forecast at that time during actually 2016 and 2018? So have you any idea on that, the accuracy that you have completed that now, that the forecast based advisory, so is there any mismatch with that accuracy?
Sir, yes, if I explain that being an island, then that is the most considerable factor for weather forecast. Then we cannot predict those things very nicely. But if we go to location specific information, then if we reduce the grid size that we try to take the information, rather taking up a large scale, then we can specifically give that information. Then if I come back to your question, in 2016 that extreme weather events were happened, then floods were happened there, then predictions were not that much accurate. Then that's why in the control group their mindset was negative towards the 2017. Then it has come as a drawback. Then they have considered that in their land utilization practices. But in contrast, in the treated group, they have built the confidence by provision of this information. Then they have identified, right, if we have this kind of weather and rainfall, then we can go to that much of land and those things. As a result, they have maximized their land utilization.
Thank you. Since we have run out of time, we'll move to the second presentation, and it's on regeneration of plantlets of tea through somatic embryogenesis in liquid dynamic medium. And may I invite the presenters, KK Ranavira, MAB Ranatunga, JP Ishwara, S. Tilakaratna, and H. Kadono.
Chairperson, ladies and gentlemen, title of my presentation, Regeneration of Tea, Cultivar TRI 5001 through somatic embryogenesis in liquid dynamic medium. First, I'll come introduction of this study. We have well-focused, well-organized cultivar development program of tea to fulfill growers' expectation. High yield, high quality, resistant to pest and disease, and drought tolerance are the most important expectation as a grower. With long time conventional cultivar development program of tea, we have developed new cultivars with wide array of attributes. If we produce large number of cultivars to growers, we should have proper mechanism to disseminate planting materials among the growers. These mainly propagated by vegetative cuttings and seeds. Though these methods are very attractive and easy methods, it has some limitation because we can't fulfill huge planting materials demand to this method because our planting materials requirement nearly 60 million cuttings per year, but we provide only 7 million cuttings per year. Then I come limitation in vegetative propagation in seeds, increase in demand and the low productivity of existing motherhood sites and seed gardens propagated by seeds, high heterogeneity, unfavorable weather conditions and high incidence of pests and diseases, slow rate of propagation, unavailability of suitable planting materials, poor survival rate at nursery, and season-dependent rooting ability of cuttings, large land area requirement for maintaining mother bush sites and nurseries. Then we should find some solution with problem justification. We should consider desirable phenotypes, genetic uniformity, mass propagation technique, excellent source for artificial seeds production, deep taproot system. With this basic information, I will come objective of this study. Broad objective, development of somatic embryogenesis proposed through different expand of new tea cultivar TRI 5001. The specific objectives are development of the suitable medium for somatic embryo multiplication through cotyledonous somatic embryos. Second, identification of the optimal culture condition for higher multiplication rate on different stages of leaf and stem nodal calli. Finally, identification of the optimum culture condition for somatic embryo regeneration through cotyledonous somatic embryos. Next, material, research location, tissue culture laboratory, Tea Research Institute, Talawakele. Plant material, cultivar TRF 5001, expand cotyledonous somatic embryos, leaf calli and stem calli. Next, I come methodology section. Here we have given common step of tissue culture technique. So we can incorporate this technique to every step of the research. Step 1, multiplication of somatic embryos derived from cotyledons. Here we have taken 7 liquid medium and 1 solid medium as the control of the experiment. The somatic embryos were subcultured to prepared media and cultures were maintained under given culture condition. Weekly observation were recorded. Step 2, multiplication somatic embryo induction from leaf color. This experiment was same as previous experiment. Weekly observation were recorded. The third step, multiplication and somatic embryo induction from stem nodule. Here we have taken 9 different liquid medium and 1 solid media as the control of the experiment. Callus was subcultured to the prepared medium and cultures were maintained under given culture conditions. Weekly observations were recorded. Finally, effect of culture conditions on somatic embryo regeneration. Here we have observed liquid and solid medium for somatic embryo regeneration. Here also same weekly observation were recorded. For each treatment, 5 culture bottles were taken. In regeneration step, 20 culture bottles were taken for treatment. Experimental design, complete randomized design, data collection, cotyledons, number of multiplied somatic embryos per initial number of somatic embryos, leaf and nodal callus, percentage of, we have taken percentage of callus proliferation, compact callus formation, embryonic callus formation, somatic embryo induction, direct plant regeneration. Data analysis, multiplication rate of somatic embryos of each treatment were analyzed by chi-square method. Embryonic callus, compact callus and callus proliferation percentage values were analyzed through probit analysis method. Mean separation was done with Duncan multiple range test at 5% significant level. Such software was used for data analysis. Next, I will come results and discussion section. Cotyledon somatic embryos multiplication in liquid dynamic medium. Here, results clearly show significantly higher somatic embryo multiplication rate was observed in TC5 medium. And then somatic embryo induction from leaf callus in liquid medium. Comparatively higher callus growth rate were observed in TL9 medium. Further, somatic embryo formation was observed in TL5 medium in leaf callus. Next, identification of somatic embryos from nodal callus in liquid medium. Here, higher callus proliferation and compact callus formation were recorded in TN2 medium, and TN9 medium was identified as higher embryonic callus formation medium. Finally, effect of culture condition in somatic embryo regeneration. Here you can get idea about the step of the somatic embryo regeneration. The results clearly show 50% germination was observed in liquid media compared with 30% germination on controlled solid medium after 12 to 16 weeks under given culture condition. Finally, I come conclusion of the research. MS liquid medium with different concentration of the growth regulators was suitable for somatic embryo induction through different explant of TRF 5001 cultivar. TC5 suitable for somatic embryo multiplication through cotyledonous somatic embryos. TL9 combination was suitable for proliferation, compact callus formation, embryonic callus formation through leaf callus, and also somatic embryos can be generated through TL5 medium. TN2 was identified as suitable medium for callus proliferation, compact callus formation, and TN9 was suitable for embryonic callus formation from nodal callus. Finally, even liquid medium was the suitable medium for somatic embryo regeneration. That's all. Thank you very much.
Thank you very much, Mr. Ranavira. Now the session is, the paper is open for discussion. Questions, any comments from the audience?
Thank you. I would like to know how economical and how would it be in the real environment when you use this embryo product at the real scale? Will it be economical for the local farmers, and will it be environmentally susceptible or environmentally okay at the real scale?
Thank you, madam. So now we have done cost calculation also. Then under conventional tissue culture technique, the cost per plant nearly 39 rupees. Under then we introduce low cost tissue culture technique. Then we incorporate this low cost tissue culture technique for somatic embryogenesis protocol. Then we can produce plant somatic embryogenesis plant the minimum with minimum cost of production nearly 11 rupees per plant.
How would it be in the environment? Will it?
Then initially we use in vitro routine system to adapt environment gradually. So in vitro routine and gradually transfer to greenhouse and then normal environment. But now we can do simultaneous routine and acclimatization. Then we can adapt this somatic embryo plant to natural environment.
Thank you.
I am Ajit. Can you hear me?
Yeah. Yes.
Yeah. I am Ajit. I have a few questions, one or two questions. One is already asked from the Professor Mettika, because this is the cost of production of compared to the cutting, right? I got the answer. The other one is, you mentioned about our requirement is 60 million and the production of the cutting is 7 million. So do you get the production information from government sector, or there are a lot of private parties produce cuttings? Did you get those information also?
Yes, sir. The TRI recommend nearly 2% replanting program. Then 2% mean consider about our total extent nearly 4,500 hectare per year. But then if we establish that much of land extent, we should propagate nearly 6 million cuttings. But we are maintain our mother bush area. We provide nearly 7 million cuttings only per year.
Okay, because the local farmers, local producers, for example, a small tea sector, there are a lot of nurseries they are maintaining in the local level, but I don't think these figures are not going to the TRI. I hope.
So, yeah, this is our mother. Then these figures mean we provide 7 million cuttings only.
Okay, okay.
Using our mother bush area, motherland.
Okay, okay. Thank you very much. Okay.
Thank you.
I'm Shriyani Piris. I would like to ask a question, and it is really a nice study because you can produce huge number of plantlets through somatic embryogenesis. What do you think of genetic integrity? Have you done, because you are going through callus culture? So
Yes.
you think, are you planning to do a genetic study, molecular marker study or something to check?
No, not madam, not now. I'm not doing genetic study now. Madam, initially we use cotyledon for somatic embryogenesis. So if you think we get cotyledons from some known cultivar, TRI 5001 or 2, then we can produce a uniform materials, genetically uniform materials through cotyledon of this known cultivar.
You mean morphologically? They are morphologically you can see that.
Same. Then now we are trying to develop somatic embryos through stem, nodal, and leaf. Then we know then if you think like this TRI 5001 cultivar, then we can produce uniform seedling using this known cultivar, the explanet of this known cultivar.
That's good. That's good.
Thank you,
As
madam.
long as they have the genetic integrity, it's very nice.
Thank you, madam.
Thank you. Good study.
Thank you very much. Right, and we'll move to the next presentation. It's on evaluation of clay brick and laterite brick as low-cost absorbent for the removal of cadmium and lead in aqueous solutions. That's by K.R. Hettiarachchi, DMSH Disanayaka, MIM Maujud, and RAS Ratnayaka. It's over to you, Mr. Hettiarachchi.
Hello, ladies and gentlemen. I am Kaushalya Hettiarachchi, representing research finding of evaluation of clay brick and laterite brick as low-cost adsorbent for removal of cadmium and lead in aqueous solutions. Moving into the introduction sessions. Heavy metals are naturally occurring elements that have a high atomic weight and a density at least 5 times greater than of water. And also the multiple industrial, domestic, agricultural, medical, and other technological applications have led their wide distribution in the environment. This can be raised in concern over their potential effect on humans and the natural environment. As mentioned in this slide, cadmium, chromium, arsenic, nickel, zinc, mercury, and lead, they are considered to be trace elements available in the wastewater generated from different industrial activities. Among those toxic heavy metals, cadmium and lead are considered to be mostly available trace element in the industrial wastewater. Wastewater can be defined as the byproduct of industrial, domestic, agricultural, or commercial activities. So based on these classification, we can go for the three groups such as industrial wastewater, domestic wastewater, and the municipal wastewater. So this kind of wastewater containing with many more toxic heavy metal. Therefore, removal of the toxic heavy metal, we need to follow some treatment method. So most probably conventional wastewater treatment method can be identified as follows: coagulation, flocculation, reverse osmosis, membrane filtration, and the ion exchange. Here you can see that heavy metal removal techniques. I mentioned above part conventional treatment method. such as the chemical precipitation, ion exchange, coagulation, flocculation, membrane filtration, electrochemical treatment method, and the flotation. By using this kind of conventional treatment method, there are few drawbacks we can find out, such as high initial cost, high operation and maintain cost, and also for conducting this kind of treatment plant, we need to have a high technology. And also this kind of conventional treatment method, we cannot applicable in the rural areas. For treating heavy metal in the wastewater, it can be industrial, domestic, or the agricultural wastewater, or the municipal wastewater. The researchers and the scientists may found that alternation method come in as the adsorption. Adsorption is recognized as a low cost and effective method for treating cadmium and lead in wastewater. And also, once we move into the adsorption method, there we can go for the bioadsorption and the geoabsorption. So construction demolition waste material also one of adsorption material or we can use for the treating heavy metal in the wastewater. So here you can see a small definition to adsorption technique. It is a better alternative treatment method, and we can characterize it as it is high efficient and effectiveness and the environmental feasibility factors. So therefore, we can use the adsorption as a technique to treat wastewater in different activities. Construction demolition waste can be defined as the waste arising from the construction industry due to various kind of demolition activity, repair, and also doing some infrastructure development. Those activities normally generate the construction and demolition waste. So these kind of construction demolition waste material we can use as a treating toxic heavy metal under the techniques of the adsorption. Then construction and demolition waste situation in Sri Lanka. That based on this chart, we can see different types of construction demolition waste material, which we can find in the construction industry in Sri Lanka and their percentage. So among those construction demolition waste material, for this research, I selected clay brick and the laterite brick as the adsorbent. The objective of this study is to characterize clay brick and laterite brick in terms of cadmium and lead adsorption properties, and to compare the maximum adsorption capacity of clay brick and laterite brick in terms of cadmium and lead adsorption. Moving into the methodologization, the first one is the adsorbent preparation and characterization. In this table, I mentioned the raw material as the adsorbent, clay brick and laterite brick, and also next I mentioned the location which I collected these raw material, and after collected the raw material, all the material crush and sieve and also air dried and also sieve to the particle size, which you can see here starting from 0.5 to 2 millimeters. So this is the particle size range which I was selected for conducting my research. So batch adsorption experiment conducted as the recommended standard, Organization of Economic Cooperation and Development 2000. You can see here that for all entire initial concentration which was selected to this study, 0 to 1000 milligram per liter under the natural pH. The investigation conducted for all particle size, and also the experiment conducted as a triplicate. So here you can see that the image step by step wise, I mentioned the way of I conduct the batch adsorption experiment. First of all, measure the known amount of adsorbent and also add 15 millimeter of that solution, cadmium or lead. Then shake that sample under 100 RPM for 24 hours at normal room temperature. After that, centrifuge all sample at 6,500 RPM for 5 minutes, and that supernatant were extracted, and the sample were prepared for the heavy metal analysis by using the ICP OES machine. So these are the adsorption isotherm model which I used to represent the how adsorbent will interact with the adsorbent. So you can see here the Langmuir model, Perundich model, and the linear model. Then moving into the result and discussion session. First of all, I explained about the physiochemical properties of the adsorbent. In this table, you can see here that depending on the selected raw material and also particle size, here measured few physiochemical properties. Then when we move into the pH, there is no any significant difference we can see in the clay brick, and by comparatively laterite brick in the first fraction, 0.5 and it is so much of less pH value coming with that comparatively the other two particle size. And you can see here the value coming of the electrical conductivity and also cation exchange capacity also. So these are the physiochemical properties of adsorbent in this study. Effect of particle size on adsorption. According to the observed data, the result lead adsorption by both clay brick and laterite brick are shown higher adsorption capacity than cadmium absorption, as you can see in this figure also. Particle size range used in this study lay within the very narrow range, 0.5 to 2 millimeter. So which might be the reason for that not showing the difference in adsorption among the different particle size in this study. The effect of initial heavy metal concentration on adsorption was investigated by the batch adsorption experiment method and at the room temperature using different heavy metal ion concentration that range coming with the 0 to 1000 milligram per liter. And this figure illustrated that the adsorption capacities sharply increase with the initial concentration of heavy metal ions. So you can see here that according to the result, the maximum adsorption capacities are differing of the initial heavy metal concentration, and that increase in initial high metal concentration, that increase in driving force at the solid liquid interference. So resulting in increase in adsorption capacity until the adsorption site was saturation. Adsorption isotherm, important to represent how adsorbate will interact with the adsorbent. And also it is very important when we are going to modeling the adsorption model in the different heavy metal adsorption into the selected adsorbent. Then here in this image we can see that the adsorption, cadmium adsorption by clay brick. There we can see that the Langmuir model fitted well depending on its high correlation coefficient, and also Fehrenrich model also cadmium adsorption into clay brick is more favorable based on its high correlation coefficient. And the linear model is empirical. The measured correlation coefficient also 0.65 in terms of cadmium adsorption by Cb. This is the cadmium adsorption by the laterite brick. Here also we can see that both classical model, isotherm models, mean Langmuir and the Fehrenrich model is favorable depending on their high correlation. These are the data which observed from that modeling cadmium adsorption parameters of both clay brick and laterite brick. So you can see here that each and every model, that all the parameters obtained by using the fitted model. Lead adsorption by clay brick and the laterite brick. First of all, lead adsorption by clay brick. So adsorption in lead onto clay brick also well captured by Langmuir and the Fehrenrich model based on their high correlation coefficient, as you can see here. Then here also you can see here the similar adsorption pattern was observed for all particle size. It means we can suggest that particle size not directly affected on adsorption lead onto the laterite brick. Here also you can see that data value, they are almost same, similar value obtained. That is because of the narrow range of the particle size. And you can see there the way of changing the maximum adsorption capacity by using different type of bricks in terms of cadmium and lead adsorption, and also based on different particle size. So after finalize all the data, we can come into those conclusions. From adsorption isotherm, the Langmuir and Fehrenrich model fitted well for entire concentration range of cadmium adsorption on the both clay brick and laterite brick. And also adsorption of lead onto clay brick and laterite brick is well captured by Langmuir, Fehrenrich and linear model based on their high correlation coefficient. And also a similar pattern of adsorption were observed among all particle size in this study, indicating that the particle size of tested adsorbent is not affecting the adsorption isotherm of cadmium and lead. And also particle size range used in this study lay within the very narrow range, which might be the reason for not showing any differences in adsorption among the different size of fraction. Therefore, it can be concluded both clay brick and laterite brick are effective and environmental friendly adsorbent to remove lead and cadmium in wastewater. Finally, I would like to acknowledge Research Facilitation Fund, Postgraduate Institute of Agriculture for their financial support, and Department of Agricultural Engineering and Soil Science, Faculty of Agriculture, Rajarata University of Sri Lanka, and also the Institute of Post-Harvest Technology, Anuradhapura. These are the references which I used to prepare this presentation. Thank you very much.
Thank you. And now the paper is open for discussion. Yeah, I think Professor Metika is waiting to ask question, right? Go ahead.
Yeah, thank you very much. I have few questions. I'm not sure about the time limitation. I'll ask one or two. Why did you select lead and cadmium is the very first question, and why they were used in very high concentrations like 1000 ppm?
Good morning, madam. That I selected those two heavy metals that they are more toxic, and in our Sri Lankan scenario in North Central province, normally we are facing that CKD diseases. So it is mainly affect lead, and also that other effect also happening with that those heavy metals, selected heavy metal, and the reason for that, they are highly affected to the people, and that both ecosystem when we are releasing these things into before treating the wastewater. That's why I selected those two material. And next question, madam.
Why in that much of the, now you said we are thinking that these are presenting in high concentrations in North Central province. Is that right?
I mean, madam, that based on the literature and the thing, we can find out.
Let's say they are present, but why did you use in very high concentrations for the removal?
Madam, that I want to check that how that adsorption behavior for selected material changes depending on the concentration value. So therefore, selected range actually 25 milligram per liter into the 1000. That's why that ranges were selected that want to characterize, I mean that study the adsorption behaviors.
Yeah, but you won't find that kind of concentrations, right, in natural environment.
Okay.
Right?
Okay.
So the adsorption behavior will change whenever you use very high concentrations. It depends on the initial concentration, right? Yes. The adsorption depends on the initial concentration. So if you use very high concentrations, the adsorption mechanism will be different. And if you use very low concentrations, like in the real environment, then the adsorption mechanism will again be different, right? Okay. So that's one of my suggestions, to use low concentrations and see. And what is your suggestion after adsorption? What would you do for these adsorbents?
Madam, that after adsorption, we need to go for desorption studies also. But in my study, I didn't go for the desorption study from that my time limit, and then therefore first I conduct my research as the adsorption, and I hope to do in further that after this thing. The way of its desorb that all the adsorbed material, and how we manage these things like.
Over to you, Professor.
Yeah, thank you. Thank you, Professor Metika. Any other questions? Right. It seems that there are no more questions on that paper. And let's move to the next one. It's on pulse width modulation control of a heat pump dryer with cascade evaporators and parallel flow condensers by A.J. Fernando, KSP Amaratunga, D.A. Dharmasena, R.M.R.D. Abhiratna, I.G. Gajasinghe, HST Veerakorn, EMS Ekanayaka, and DMSP Bandara. Right. So over to the presenter.
Hello everyone, I'm Jerry Fernando. The research study that I'm going to present was done as a part of my PhD project at the Postgraduate Institute of Agriculture, University of Pennsylvania. The study is on pulse width modulation control of a heat pump dryer with cascade evaporators and parallel flow condensers. Here I have listed all the authors and the affiliations of the authors. Drying is one of the most popular post-house treatment in the world to reduce spoilage and increase the shelf life of the agricultural products. Moisture removal in the drying process is happening due to simultaneous heat and mass transfer processes, and agricultural commodities need different temperatures to produce optimum quality products, as well as the temperature requirement during the drying process is vary throughout the time. We can use hot air in the temperature range of 45 to 60 Celsius for the safe drying of agricultural products. Controlled temperature and relative humidity during the drying process is a challenge in the food industry. And if we can control the temperature and relative humidity during drying, it ensures better quality of agricultural products. So we can consider the heat pump drying technique for this purpose. This schematic diagram shows a typical heat pump drying system. There are two major components in the heat pump drying system. One is the heat pump unit, and this is the drying chamber unit. The heat pump unit consists with four major components. That's the evaporator, compressor, condenser, and expansion valve. The heat pump units are connected with the refrigerant, and the heat pump unit and the drying chamber is connected through the air path. I'll describe this heat pump drying system starting from the evaporator from here. So inside the evaporator, the refrigerant evaporates. To evaporate the refrigerant, it needs energy. So energy is absorbed from the surrounding environment. So the air coming out from the drying chamber, which is moist, warm air, is supplied to the evaporator, and that air supplied energy for the refrigerant evaporation process. So since air is supplying energy for the evaporation process, the dehumidification of the air is happening as well as air get cooled. So this cool dehumidified air is provided to the condenser. If I talk about the refrigerant inside the evaporator, I said that the refrigerant evaporates. So this evaporated refrigerant, which is in vapor state, is compressed in the compressor by getting more energy as electrical energy, and that compressed energy, compressed refrigerant, is provided to the condenser. Inside the condenser, the condensation process is happening of the refrigerant. While condensation process is happening, the refrigerant dissipates energy to the surrounding environment. So the air coming out from this evaporator, which is cool dehumidified air, absorb energy which is dissipated due to refrigerant condensation, and the air gets heated, and this hot air is provided to this, hot dehumidified air is provided to this drying chamber. Inside the drying chamber, the wet product get dried due to the heated air. So this is the typical heat pump drying process. On the other hand, if we consider the technique pulse width modulation, pulse width modulation is a command controller and a method of reducing the average power by pulsing its electrical signal by effectively chopping it up to discrete parts. You can see in this image, GIF, how the light intensity is controlled of an LED by different width of pulses. The narrow pulses provide less intensity, light intensity, and wide pulses provide high light intensity. So the pulse width modulation technique with duty cycle provides a measure of controlling the voltage supply to the electric motors. This diagram shows how low voltage supply from narrow pulses and how high voltage is supplied through wide pulses. The pulse width modulation control of an heat pump dryer with cascade evaporators and parallel for condensers to manipulate the air circuit parameters is the objective of this research. We designed and fabricated the heat pump drying system at the Department of Agriculture Engineering at University of Pennsylvania. Here you can see the schematic diagram of the developed heat pump drying system. The chamber B represents two indoor units of an air conditioned systems in series, and chamber A represents two outdoor units in air conditioned system in parallel. So the evaporators are in chamber B and the condensers are in chamber A. The drying chamber has direct inlet from the chamber A and direct outlet to chamber B. The air circulation path is shown in these blue lines. So in this study, we wanted to regulate the temperature of the outlet of chamber A. A control system was developed to regulate the drying chamber inlet air temperatures. Mainly Raspberry Pi 3 model B+ and SSR models were used for this purpose, and we used Python programming language to develop the code. We developed the data acquisition system using 6 DHT22 sensors, which we can measure the temperature and RH of the air. And we connected these 6 DHT22 sensors to a Raspberry Pi for the same Raspberry Pi we used earlier. So the earlier code was further developed to acquire data from the system. The chamber A inlet and outlet temperatures and relative humidity values were recorded, and the average values were calculated. We developed an Excel-based psychometric calculator using the equations in ASHRAE Fundamentals 2013. Here you can see the equation that we used for develop the Excel-based psychometric calculator. We analyzed the temperature variation in the drying chamber inlet due to the pulse width modulation control using energy conservation principle. The energy supplied to the condenser is equals to the energy released to the air. So the enthalpy difference, here you can see the enthalpy difference of the output and input air in the chamber A into mass flow rate provides the total energy supplied to the chamber A, which has condensers. We selected 60%, 80%, and 100% duty cycles for this study because the duty cycles above 60% were only provided a considerable air velocity. The average temperature and relative humidity at the chamber A inlet and outlet were recorded using the program for 20 minutes after the system got stabilized. Then a psychometric analysis was conducted using the Excel-based psychometric calculator. The developed model was analyzed using the data from the psychometric analysis. Here you can see the developed heat pump dryer, and here you can see the pulse width modulation control system. These three figures shows the variation of chamber A inlet and outlet temperatures at different duty cycles, that's 60%, 80%, and 100%. The chamber A outlet temperature is higher than the inlet temperatures at all the time. The reason was that heat is dissipated due to refrigerant condensation process happening in the condenser. The condenser inlet and outlet temperature differences were 13 Celsius, 12 Celsius, and 11 Celsius for 60, 80, and 100% duty cycles. The condenser outlet temperature varied with duty cycle. In this table, you can see the temperatures decreased with increasing duty cycle. The chart shows you the linear relationship between the duty cycle and temperature. This is in line with the findings of Poetel 2021, which stated that change in the motor frequency, the capacity output rises, decreases, and the capacity modulation supports for accurate temperature and humidity control. This chart shows the variation of energy generation rate at chamber A with different duty cycles. We used Excel-based psychometric chart as a tool in developing a relationship with the enthalpy difference at different time intervals. And then we calculate the energy consumption here using the developed model. The heat energy generation rate was reduced with increase in duty cycle. We can see that high heat energy generation is shown at low duty cycles because of higher energy accumulation, because of fewer heat generation transfers from the refrigerant to the air. In conclusion, the drying chamber inlet temperature was controlled accurately using the developed program and hardware for pulse width modulation control system. The refrigerant condensation process generates heat energy. The heat accumulation at chamber A is higher at lower duty cycles, and the pulse width modulation control system could be successfully applied to the heat pump dryer to manipulate the air circuit parameters. Here are the references used in this study. And thank you very much for your attention.
Thank you very much. And now the paper is for discussion. It's available for discussion. You can ask any questions and also make any comments. Over to you, the audience.
It looks like the water use might be giving some difficulty for energy conversion, right? Don't you think that there will be some energy loss because of the use of water through the pump system?
Madam, are you asking during the process or the water? Actually, the system uses a refrigerant. The heat pump system uses a refrigerant, and the air is circulated throughout the drying chamber as well as the heat pump units to move
so the air will get
the,
some moisture, right?
Yeah, get moisture from the product.
Yeah.
So that's what we wanted to analyze, and in here as a part of this study. So that's why we developed Excel-based psychometric calculator to see the effect. So at that point, with the psychometrics, we can find the relationship with the relative humidities and temperatures. So we can get an idea how the temperature is going to different at the chamber inlet, drying chamber inlet.
Okay, so governing factors you are incorporating to the psychometric calculator.
Yes.
So don't you think there will be energy conversion problem because of the air having moisture in there?
Yeah, all the time air is having moisture because of in the dehumidification process in the evaporator, although the moisture is removed, but during the process always there is somewhat moisture in the air, so that affect the drying process.
So the air which is flowing to the product will not have moisture. Is that right?
It has somewhat of moisture. It's not totally dehumidified. It has somewhat of moisture. So the factors are getting different with the amount of moisture. But basically, in this study, we focused on the relative humidity, and also basically actually the temperature. How to increase the temperature in this drying chamber inlet, that is in the condenser outlet, how we can increase the temperature. So we basically focused that point in this study.
Okay. All
So
right, thank
accordingly,
you.
the temperature, accordingly, the relative humidities are going to be changed always. But we focused the temperature factor only at this point.
All right, thank you. Over to you, sir.
Thank you. Any other question? You can accommodate one more question. Right. Since there are no more questions, thank you. And shall we move to the next presentation? It's on modeling the particle size distribution of pulverized gold nuts by EMAC Ekanayaka, KSP Amaratunga, and AJ Fernando.
I'm Asanka Ekanayaka. My presentation title is Modeling the Particle Size Distribution of Pulverized Gold Nuts. Gold nut is an insect board, and gold nut extracts are extensively used as a pharmaceutical and food and feed additives. In Sri Lanka, it's main ingredient of the herbal extract of toothpaste. When we consider about the herbal extraction, particle size is very important because it's maintain the uniformity and the required particle size is essential for the increase in the extraction efficiency. Grinding or milling is an essential unit operation to reduce the size of solid dry materials. In the milling process, considerable amount of energy is wasted as heat in grinding process, and approximately 1% of energy is used for the size reduction. In the walnut milling, it is used high amount of fine particles because of the moisture content of the walnut is very low. And the for the extraction procedure, optimum particle size is around 3 millimeter. But in the industry, it gives high amount of particle size lower than the 3 millimeter. For that, controlling the moisture content of raw material is to an optimum level will enhance the particle size uniformity and the milling yield. The objective of this study was to identify the suitable empirical model for the particle size distribution of pulverized gold nut and subsequently to determine the selected size parameter and the distribution parameter for the particle size distribution at different moisture contents. In the methodology, first one is the preparation of samples. And the dried gold nut with the moisture content around 11%, dry basis moisture content 11%, were procured from a local company importing them from Iran and India. Then samples were prepared at different moisture contents, 0, 9, around 9%, around 11%, and around 19% dry basis moisture content. For this obtaining 0 point moisture content, it was oven dried the clean gold nut at 105 degrees Celsius for until constant weight. And then for the 9.16 moisture content, first sample were dried at 40 degrees Celsius to reduce the moisture content with minimum effect of temperature and obtain 0.95 dry basis moisture content. And those samples were used to obtain 9.16 dry basis moisture content through the moisture adsorption in controlled environment. And for the higher moisture content, samples were soaked in water and dried to obtain 19.1 dry basis moisture content. And then grinding and sieve analysis. 350 grams of gold nut were fed to the grinder for 1 minute of grinding for each experiment. A laboratory sieve shaker and set of standard sieves were used for the sieving process. And sieving time was 30 minutes. The fraction retained on each screen are removed and weighed for the calculation of weight fraction. And this is the sample of pulverized gold nut. And then mathematical model for the particle size distribution. And widely used two mathematical models were used. First one is RRB model and second one is GGS model. And this is the particle size obtained in the sieving. And you can see here when the moisture content is increasing, amount of fine particles are decreasing, and cutoff diameter of the particle size distribution. In here also, when the moisture content is increasing, mass fraction of higher particle size is increasing. This graph shows the particle size distribution curve. Y-axis is cumulative undersize mass fraction and x-axis is particle size. In here also, when increase the moisture content, amount of fine particles is decreasing. And this graph shows the particle size distribution as regressed by the GGS model at different moisture content. A GGS model gives high R-squared value for the all four moisture content. This graph shows the particle size distribution as regressed by the RRB model at different moisture content. This RRB model gives lower R-squared value than the GGS model. And this is the statistical and model parameters. GGS models gives the high R-squared value and lower values of residual sums of square and root mean square error than the RRB model for the particle size distribution of pulverized gold samples at each moisture content. Here you can see in the RRB model, R square value is lower than the GGS model R square value, and the residual sums of square and root mean square error also lower than the RRB model. And these are the model parameter. Statistical and model parameters. The distribution parameter of the GGS model increases with the increasing in the moisture content. The size parameter XD was increased with the increment of the moisture content and indicated the fraction of the higher particle size increases with the increment of the moisture content. The distribution parameter gives this exponential relationship with the 0.9502 R squared value, and the size parameter gives this exponential relationship with the 0.99 R squared value. This XMC is the dry basis moisture content of the material. This is the size parameter for the particle size distribution. Essential parameters related to the particle size were evaluated for the better prediction of particle size distribution with moisture content. The first one is size guide number. Size guide number is the median of the particle size equivalent to the cumulative undersize mass fraction of the 50%. Second one is the effective size. Effective size is the size that 10% of the particle size is smaller than that size. And other distribution parameters are mass relative span, uniformity index, coefficient of uniformity, coefficient of gradation, graphic mean, inclusive graphic standard deviation, graphic kurtosis, inclusive graphic skewness. And these are the calculated values for the size and distribution parameters. And you can see here, size guide number is increasing with the moisture content. And the effective size also increasing with the moisture content. That's indicated the particle size increase with the moisture content. Finally, conclusion is the GGS model produces a good fit for the particle size distribution over the entire cumulative weight fraction range with the higher coefficient of determination value than the RRB model. And it can be concluded moisture content directly affect the particle size distribution and uniformity of the particle size distribution of pulverized gold nut. These are the references. Thank you.
Thank you. Any questions and comment on the presentation?
I'll be
Yes,
asking one question.
yeah, please.
What will be the influence of the data that the data that you have found from this research? How do you convert it into the real scale or to the application?
Actually, madam, this research done collaboration with the Link Natural Private Limited,
And their issue is a goal nut. When grinding the goal nut, they have high amount of fine particles. In the extraction procedure, that fine particles cannot go through that process line because the clogging in the machine and those things happen. Therefore, we try to increase the size of the particle by increasing the moisture content of the material before the grinding. That's not only the gold nuts, there are research on other materials also. Aralu, Bulu, Nelly, actually, those herbal products also they are.
But when the moisture increases, will not that affect the grinding?
It's according to this data, and for the gold nuts, it increases the particle size when they increase in the moisture content before the grinding.
Yeah, yes, exactly, yes. But will not that affect the grinding, because when the moisture content is high?
High moisture content is high mean not too much high moisture content. It's
so you have to control it in a way.
In this presentation, maximum moisture content we use 19 point dry basis moisture content. That is the maximum moisture content that can grind material.
How can you control the moisture content in these nuts?
These nuts using a closed chamber. That means inside the closed chamber, we can control the relative humidity. By controlling the relative humidity, this material get equilibrium with the surrounding air by absorbing the moisture.
So you think your research will be useful for the company to process?
Yeah.
Okay, great. Thank you. Over to you, sir.
Yeah, thank you, Mithila. Any other questions from Mr. Sasankar? All right, so thank you, Mr. Ekanayak, and then we'll move to the last presentation of this technical session 5. That's on assessment of mobile-based extension service usage by medium-sized tea growers in Kandy district, Sri Lanka, by KG MJW Gunapala, UI Disanayake, and C. Munasinghe.
Good day, ladies and gentlemen. I am going to share with you our research findings on assessment of mobile-based extension service usage by medium-scale tea growers in Kandy district, Sri Lanka. The tea industry of Sri Lanka plays an important role not only in the economy but also socio-cultural and political scenarios in the country. Also, medium-scale tea growers have been identified recently as a separate group of tea growers, and they own 10 to 50 acres of tea lands. However, they are not directly engaging in the exclusively designed extension programs offered by the government institutes like Tea Research Institute of Sri Lanka and the Tea Small Holdings Development Authority. Also, there are limited number of research to estimate the level of mobile-based extension usage by medium-scale tea growers. Then the mobile-based extension can be identified as a new approach that is applicable in a wide range of knowledge dissemination. Also, mobile-based extension in tea industry facilitates the communication between the factory and tea growers, easier access to extension services, and generates more accurate and comprehensive information. This table shows some tea-related mobile-based extension services that are currently operating in Sri Lanka. Both public and private sector organizations support tea growers by offering different types of these services. Among them, TRI SMS service shares timely relevant information among tea growers and extension officers. The key factory SMS service mainly shares price information among leaf collectors, as well as both Goimithru voice message service and mobile application share technological information on tea cultivation among their users. Also, some Facebook pages and WhatsApp groups have been initiated to share different types of information in tea industry. By considering this all information, our study is carried out to assess the usage of mobile-based extension services among medium-scale tea growers in Kandy district, Sri Lanka. Also, there were 3 specific objectives to determine the level of awareness and usage of mobile-based extension services among medium-scale tea growers, user perception of currently used mobile-based extension services, and factors associated with the awareness and usage of mobile-based extension services among the target group. This is the conceptual framework of our study. Personal factors, technological factors, and perception of mobile-based extension service users were considered as independent variables. The major dependent variable was the usage of mobile-based extension services, and the awareness was considered as an intervening variable in the study. Then the methodology. Our research design was the cross-sectional design. The list of registered medium-scale tea growers in Kandy district under Sri Lanka Tea Board was used as the sampling frame for the study. Also, 56 medium-scale tea growers was selected as the sample by simple random sampling method to obtain a more representative sample. A pre-tested survey questionnaire was used as the data collection instrument, and the telephone survey was selected as the primary data collection method. Finally, data analysis was done in SPSS by using descriptive analysis methods and Pearson chi-square test. Now I will start to share our research findings. This pie chart shows the majority of medium-scale tea growers have made their education up to advanced level. Also, more than 25% of respondents have made their education up to diploma or degree level. Next, according to this table, the majority of respondents are having 6 to 15 years of farming experience, and 30% of medium-scale tea growers are having 16 to 25 years of farming experience under tea cultivation. Also, the majority of medium-scale tea growers are using smartphones. When consider about the media format preference of medium-scale tea growers, 41% of respondents mostly preferred videos as the media format of information. However, a significant percentage of medium-scale tea growers prefer other media formats, including pictures and infographics, voice, text, and interactive content also. This indicates that use of one single media format for sharing information among medium-scale tea growers is not applicable. In our study, 7 mobile-based extension services related to tea cultivation were considered. According to the findings, more than half of respondents are not aware of at least one of these mobile-based extension services. Only 46% of respondents are aware about Tea Factory SMS, and 41% aware about 1920 Agriculture Advisory Service. Then, this is about the usage frequency of these mobile-based extension services. Among aware respondents, significant respondents are never used GRI SMS service, 1920 Agriculture Advisory Service and Govimitru mobile application. However, all the aware respondents of Facebook pages are using Facebook to share information. Next, I will explain about the user perception of currently used mobile-based extension services. According to this table, most of mobile-based extension service users agree with the first three statements. It indicates that currently using mobile-based extension services are capable in addressing cultivation-related problems and they provide understandable, timely, important information to tea growers. Also, the majority of respondents disagree with the fourth statement and it shows that using mobile-based extension services helps to save their time. However, the majority of mobile-based extension service users disagree or remain neutral with the fifth statement. It indicates that there may be a problem with the capability of knowledge improvement via currently used mobile-based extension services among medium-scale tea growers. Then I will explain about the factors associated with awareness and usage of mobile-based extension services. Based on the results of Pearson chi-square test, the awareness of mobile-based extension services among medium-scale tea growers shows statistically significant association with educational level of respondents. However, awareness of mobile-based extension services does not show any association with other factors including age, gender, farming experience, involvement time, state ownership, and internet access of respondents. Also, the usage of mobile-based extension services among medium-scale tea growers shows statistically significant association with the educational level and internet access. However, usage of mobile-based extension services also does not show any association with other factors. Finally, we concluded that most of medium-scale tea growers do not use mobile-based extension services related to tea cultivation, and the probable reason would be the less awareness of these mobile-based extension services. However, there is a high potential to use smartphone for sharing information among medium-scale tea growers in terms of education, higher usage of smartphone and the internet. Further, it is needed to assess the information need of medium-scale tea growers before designing mobile-based extension method. Also, it is suggested to develop a single ICT platform to support all media formats for sharing information among medium-scale tea growers and improve current mobile-based extension services in order to make them more user-friendly and more technology transfer-oriented. As well as it is recommended to conduct awareness programs on current mobile-based extension services, and comparative studies are needed to compare the usage of mobile-based extension services in other tea growing regions also. These are some of my references. Thank you.
Thank you. Now the paper is open for discussion. Any
Thank you
questions?
very much. Thank you very much. It's a very good presentation. So I have a question because the mobile application are widely used for the agriculture sector in other countries, but your presentation mentioned they are not aware about the applications, mobile-based application on tea sector. What are the reason for that? This is very important. Why they are not aware the mobile-based applications?
Thank you, sir. Based on findings on my study, based on the medium scale tea growers in Kandy district, they are mainly depending on the conventional extension methods such as field visit, training programs, crop clinics like this. And they do not use this mobile phone to get some tea-related information about their cultivation problem, pests and diseases such as that problems. They do not use mobile phone. They already use social media, then other social media platforms like WhatsApp, Viber, Facebook, but they do not use that platforms to get knowledge about the cultivation problems. That's the reason.
Okay, that's good. The other thing is the mobile-based applications.
I think Dr. Ajit, you are not audible. Yeah.
Do you suggest one-way communication or two-way communication platforms? What do you suggest about the mobile-based communication system? Because one-way communication is you getting the information, farmers getting the information only. But in the two-way communication, farmers input their information to the Department of Tea, whatever what is called the mobile application developer. What is the suggestions about?
Actually, sir, I suggested two-way communication methods because there may be a feedback method to get the information. Actually, we want to know about the information correctly, share with the farmers or any other stakeholders, and we want to get the feedback of them. Therefore, two-way communication methods are needed for information sharing among tea growers as well as other farmers in Sri Lanka, because problems are based on the farmers, and some farmers having more experience and other things than the our sector, because based on the extension.
Thank you. The one last suggestion I think rather than the mobile-based application, most of the farmers and other organizations like to use social media platform. They are developing their own groups and sharing the information. What about what I think about that aspects?
Yes, sir.
What are the suggestions?
Currently, Sri Lankan farmers and others also using social media rather than the other mobile applications. Therefore, we can go for the social media also, because we can design extension programs to achieve different types of media formats using social media. Therefore, it is a good solution for extensions also.
Exactly. Thank you.
Thank you, sir.
Any other questions? Right. Now, one of the findings from your study shows that this education level is strongly linked to the use of this mobile applications. And I also have seen somewhere that this adaptation to climate change, especially in mine irrigation tanks, also has the same link, because that study, they have tested nearly 20 parameters, and then education became a very strong one, which has a statistical significance to this climate change adaptation. Why do you think that education is becoming more important and becomes very significant in all these aspects?
Actually, sir, in this study, most of medium-scale tea growers having higher education levels. And also based on previous studies, the education level is higher education level help to more aware about new technologies, as well as it more helpful to get the new knowledge about current situations. Therefore, I think the education level significantly associated with the both awareness and usage of these mobile-based extension services. That's the reason.
Thank you. Any other questions? Right. Thank you very much. And so we had 6 presentation in this session, and before conclude, I would like to thank the organizers for inviting me to chair this session, and then special would like to thank 3 judges, Professor Metika Tanage from the Faculty of Applied Sciences, University of Sri Jagadhanapura, and then Dr. Ajit Gunawardena, Acting Director, Research and Development, Central Environmental Authority, and then Dr. Harsha Kadupitiya, the Director of the Natural Resources Management Center of the Department of Agriculture. Thank you very much for being here and participating in this and taking a very difficult task of selecting the best presentation. And then I would also like to thank the 6 presenters for their very nice presentations. You have done well. Then my session coordinators, Mr. Chamika Anuradha and Mrs. Sevandi Chandrasekhar and Mrs. Chamali Vikramasinghe, thank you very much for helping me to conduct this session. And then the audience for their participation and active involvement during the session. And with that, I would like to conclude this technical session. Thank you very much. Over to you, Chamika.
Yes, thank you very much, sir. So I have a small announcement to our judging panel. Dear sir and madam, please make sure that you have provided, you're filling the provided evaluation sheet, and hope you can do that by now. And you can finalize the marks since we are done with all the presentations. So with this, we are reaching to the end of this session. So Nimal sir, thank you very much for chairing this session and conducting the discussion in most fruitful manner. Let me also thank the panel of judges for their active presence and their interesting questions, and also for the presenters for their valuable contribution in making this session a great success. At this moment, I would like to announce a few notices on the upcoming events of today's program. We shall start the invited presentation by Professor Diane Bickles from University of California, Davis at 1:30 p.m. You all can join with it through the Zoom link provided for the main event. Now we have another exciting presentation for you. PGIA has a pioneer in the postgraduate education in Sri Lanka, which offers programs in over 31 different disciplines. So these programs offered through different boards of studies. Let us take a moment to view the posters prepared by the Board of Studies introducing these degree programs. So we will move on to this video presentation. Thank you very much for your kind attention on our programs. Please note that the video of this technical session and the introduction of Board of Study will be available on the YouTube channel dedicated for this event. Thank you very much again for joining with us. So let's meet again at 1:30 p.m. Thank you very much.